Text. National Museum of Natural History. Smithsonian. Hot topic. Keeping Up with Human Evolution, featuring Sandra J. Ackerman, contributing editor, American Scientist magazine. May 22, 11:30 a.m. to 12:30 p.m. ET.
Hi, everyone. Welcome to today's Hot Topic Human Origins Today topic program, Keeping Up with Human Evolution with Sandra Ackerman. My name is Briana Pobiner, and I'm a paleoanthropologist and educator at the Smithsonian's National Museum of Natural History. I'm a brown and gray-haired woman in a green shirt wearing headphones in front of a Zoom screen with an African savanna photo with grass and an acacia tree behind me. Whether this is your first time joining us or you've attended before, we're so glad to have you here. Before we get started, I have a few housekeeping notes. This discussion offers closed captioning. You can turn the captions on or off via the CC button, which should be located at the bottom of your Zoom interface. We're in a webinar format, so we can't see or hear you. As you have questions, please go ahead and submit them to the Q&A box, which is at the top or bottom of your screen. It looks like two speech bubbles. So we want to sort through as many of those as possible because the Q&A time really flies by. The Q&A box is also where we might share any relevant links during the program, so you can keep an eye out there. So we'll start with an opening presentation by our speaker, Sandra Ackerman, and then I'll join her here to take your questions. During the presentation, I will also write answers to some of your questions, at least any that I can answer, as will another member of our behind the scenes team, Dr. Ryan McCrae. So now I'd like to go ahead and introduce our speaker. Sandra J. Ackerman is a freelance writer and editor, specializing in human evolution, anthropology and archaeology, neuroscience, mental health, and mental illness. She's the author of 2 books and more than 150 articles, features, interviews, and news reports on scientific developments in the United States and abroad. She is currently writing a proposal for a book on human evolution for the general public with the working title, What Makes Us Human? Who We Were 300,000 Years Ago and Why It Matters Now. Based in Durham, North Carolina, she is a member of the National Association of Science Writers and a contributing editor at American Scientist magazine, which is published by Sigma Xi, the Scientific Research Society. And now I'm really excited to hear Sandra's presentation.
Thank you, Briana. And I'd like to thank the Human Evolution Program and the Human Origins Today program at the Smithsonian Institution for inviting me to give this talk. And I'd like to thank all of you for joining me virtually for this talk, which I've titled Keeping Up with Human Evolution. I should explain right away that I've given this talk the title Keeping Up with Human Evolution because as a science journalist rather than a researcher myself, I find the major challenge is simply to keep up with all the information that keeps coming out as studies progress in human evolution. There are new sites of early human habitation still being discovered and explored. There are many new technologies that are being developed and have been developed in the last couple of decades that allow for studying fossils and artifacts and even samples of soil from these ancient sites. And sometimes these new technologies can be applied even to sites that had already been studied and can turn up new information there. And an image that I'd like you to keep in mind throughout this talk is that of people trying to assemble an enormous jigsaw puzzle without the aid of the picture on the lid of the puzzle box.
A newspaper headline reads, New Light on the Baffling Problem of Man's Origin. The discovery of the Peking man suggests the probability that the continent of Africa was the first home of the human race. An image on the left depicts a reconstruction of Peking man, and on the right a reconstruction of the ape man of Java.
Okay. So for some historical perspective, I want to show you this newspaper article from 1932, which more or less sums up the state of knowledge about human evolution at that time. And it, as you can see, baffling was was pretty much the state of knowledge at that time. These two sketches show an artist's rendering based on fossils that had been found already. On the left was a fossil of an individual termed Peking man, because this fossil was found near Beijing. And on the right was an individual named the ape man of Java, found on Java, Indonesia. Both of these fossils are now classified as Homo erectus, but at the time they were first found, they were not thought necessarily to belong to the same early human population, and it just wasn't at all clear how or whether they were related to each other at all. Each of these two gentlemen lived at least 700,000 years ago, but since the time of this newspaper article, almost 100 years ago, many, many more fossils and traces of Homo erectus have been found, and it's now clear that Homo erectus dates back to at least 2 million years ago, and that this early human ranged very widely all across Eurasia.
Below a black and white photo of four men, text, Figure 4. As a museum conservator, Ruto maintained good contacts with private collectors. This photograph is from one of his excursions with bourgeois amateur geologists.
And now for a different historical perspective, I want to show you a photo of an excavation that took place sometime between 1910 and 1920. It's of interest to note the very small local area that seems to be being excavated, and also the very rudimentary tools that were used. I think there's just a pickaxe and some canvas bags for collecting samples. And a kind of striking contrast to that is the formality of the researchers' dress at the time. And now I want to show you a modern day excavation. This is an excavation at a very famous site called Atapuerca in Spain, and this is still ongoing. And you can see that there's an elaborate and quite sturdy scaffolding that's been erected. The excavation site is pretty large, and the scaffolding is there to keep parts of the cave roof from collapsing on the researchers. And what you can't see, but what is very important to know, is that on the floor of the cave, where the researchers are currently digging, there has been a grid laid out, 1 meter square grid all the way across the floor. And everything that comes from this excavation will be tracked according to which grid on the floor of the excavation it came from. Okay. Here I want to show you what happens after things are dug up or carefully extracted from a site. On the left, people are running the yield of the excavation through sieves, and the sieves trap all kinds of objects, even quite small ones, fragments of bone or tooth or flaked stone or charred wood or anything really that's large enough to be visible. And each of those objects will be studied on its own. But also all the sediment that passes through the sieve is laid out, as you can see at the right, in piles according to which grid of the cave floor it came from. And that soil that has passed through the grid will also be studied further. Okay, and now we have a typical lab photo. And what's important to notice here is the great care that the researcher is taking to avoid letting anything extraneous get into the sample that's being studied. No outside air, nothing from the atmosphere of the lab itself, no microscopic skin particles or even a few molecules of the researcher's cologne. Nothing is to be allowed to contaminate and confuse the results of the sample that's being studied. Okay, and now we come to the first of three caveats. These are principles that I very slowly realized in my years of writing about human evolution, and they may seem obvious to you. They were not obvious to me, but they can be hard to keep in mind. And the first one is that we don't yet know what hasn't been discovered. And especially in the study of human origins, when nobody knows how many of the original puzzle pieces will ever come to light, any new fossil fragment or new data point has the potential to confirm current theories or even possibly to overturn them. And it's always possible that the next site will turn up evidence for a previously unknown type of human ancestor. And to allow for this possibility, every scientific account carries the sort of implicit caveat, given what we have found so far, this is what we think was going on. Okay, back to historical perspective. Here we have a sketch that was produced by the eminent biologist, anatomist, and anthropologist Thomas Henry Huxley, and he titled this The Ancient Ape Man of Gibraltar. The sketch was based on a fossil skull that had been found in Gibraltar in 1848, but hadn't yet been scientifically identified. And reportedly, Huxley drew this while he was bored in a meeting. And Huxley may be a name that's well known to you as a vigorous defender of Darwin's theory of evolution. And in fact, he earned the nickname Darwin's Bulldog. Okay, now into the present day, we're going to, I will introduce to you this life-size reconstruction of a Neanderthal man.
The Neanderthal man wears a suit jacket and blue button-down shirt with his short gray hair swept to one side.
And this figure is a resident at the Neanderthal Museum in Mettmann, Germany. And as you can see, in modern dress, he doesn't look instantly different from people you may pass on the street on any given day. He has earned the nickname Stone Age Clooney, and I'll just leave you to ponder that. And now I'm going to come to my second caveat, which is that the environment in which a fossil is found today probably differs from the animal's original environment. We have to remember that the climate of any given region, the plants and animals, and even features of the landscape will have changed, sometimes changed greatly over time. These changes take place very slowly. They may not be noticeable within any one person's lifetime, but over dozens or hundreds of millennia, they add up to a big difference. And one particularly dramatic example of this comes from the Arabian Peninsula, where the fossilized bones of hippopotamuses were found underneath an area that's now a huge desert. And during the last few million years, this region changed repeatedly, transforming into and out of what has been termed Green Arabia. And as you can see on this map of Green Arabia, there was evidence of long ago rivers that are now extinct. And there was fertile land that was inhabited by all kinds of plants and animals, including early humans. And all this was found underneath many thousands of years worth of dry sand.
A world map focused on the continent of Asia marks a pin to the north between the regions of Kazakhstan and Mongolia as the Denisova cave within Russian territory.
Now we're going to go to a very different part of the world, to Siberia. And the site highlighted here is Denisova Cave in the Altai Mountains of Siberia. This is a site that has only recently, again, in the last couple of decades, become very famous. And I want to show you some researchers painstakingly excavating the floor of Denisova Cave in this next slide. And the reason the site has become very famous is for the finding of this one tiny fossil that you'll see is in the next slide, is a part of a pinky finger bone.
The tiny bone sits atop a live human's pinky finger.
And here you see it in context of a modern day hand. You can see how small it is. The individual from whom this fossil came is thought to have lived between 52 and 76,000 years ago. And the reason this became so famous, and Denisova Cave became so famous, is that it's from this fossil that researchers were able to extract DNA that allowed them to claim the existence of a human population that had previously been completely unknown. The Denisovans, named for Denisova Cave, obviously. And we can think of Denisovans as a sort of sister lineage to Neanderthals. They lived about 200,000 years ago, up to perhaps 50 or 60,000 years ago. And they lived across Eurasia, while the Neanderthals were more in, they lived in Eastern Eurasia and East in Asia, while the Neanderthals were ranging around in Europe and the very western edge of Eurasia. And for quite a few years, there were just a dozen or so fossils of Denisovans found, but now traces have been found going back, as I said, to 200,000 years ago. And they've been found in environments as different as Siberia, the mountains of Tibet, Laos, and possibly even islands of the South Pacific. And this brings me to the third caveat, one that's maybe the most obvious, but it's also very hard to remember when we're deep in the technological minutiae. The terms that we use today to make sense of human evolution didn't exist and would have made no sense to the ancestors whose lives we are trying to understand. That is to say, many of the categories we use, like Neanderthal or Denisovan, or even the place names we use today, simply didn't exist at the time that these people were living. If a Neanderthal woman had sex with a Denisovan man, or if a band of early Homo sapiens walked across a stretch of land from what we now call Africa into Arabia, they would have had no idea that they were making a daring advance in the evolution of humanity. They were just getting on with their lives. And I think it's important to understand this, and it's very easy to forget. But I have here a cartoon that helps a little to put this in context. If you take the term early man and put it in a different context from the one where we usually use it, and this caption, in case it's difficult to read, shows early man, annoying later in the day man.
The cartoon depicts the early man breaking stones outside a cave while the later in the day man sleepily rubs his eye.
And any of you who have lived with or even near small children who insist on waking up at the crack of dawn and running around or bouncing a tennis ball against the garage door will know exactly how later in the day man was feeling here. Okay. Now, another limitation with terms like early man or Peking man is, of course, that it leaves out half the population. And in recent years, there's been more information uncovered and more interest in the lives of early human females. What we have here is a set of portraits of Paleolithic women. And as you can see, they are taking part in many of the main activities of daily life. And this is a set of portraits by the artist Tom Bjorklund.
The women in the portraits hold spears, carry children, and one holds an animal's severed antler.
And here is another portrait by Tom Bjorklund. This shows Bjorklund's rendering of the first genetically confirmed father-daughter pair that was found among the Denisovans. And as you can see, although they lived a very long time ago, the position that they have here and the way they're interacting looks completely familiar to us today.
The father holds the young girl on his shoulders with her hands clasped around his neck.
And I think it's just helpful to keep that in mind. Okay, now going on to the idea of these early humans not thinking of themselves as Neanderthals or Denisovans, what we have here is the artist's rendering of a child who became a scientific celebrity because of her parents. One, her mother was a Neanderthal and her father was a Denisovan. And the genetic evidence from this fossil proves that these two populations were able to interbreed.
The image on the left depicts a red-haired person with a large nose, heavy brow bone, and fair skin.
This was a 13-year-old girl, and she's been given the name Denny. And she lived probably about 90,000 years ago. And again, this is from Denisova Cave. Now I'm going to show you some artists' reconstructions of other early human populations. Here we have Homo floresiensis, named for the island of Flores, where these fossils were found.
The elderly brown-skinned female squints narrow eyes and wears a soft smile.
That is of the island of Flores in Indonesia. This population was nicknamed hobbits for their small stature. The adults grew to only about 3.5 feet tall, and they're estimated to have lived sometime between about 1 million years ago and perhaps 50,000 years ago. Not a very precise estimate at this time, but we can always hope more will be found. And next we have an artist's reconstruction of Homo longi, who you may have heard of as Dragon Man.
The side profile depicts the male with a heavy brow bone, long brown hair and long thick facial hair, a beard and mustache.
This individual received the name Dragon Man not for his intimidating, robust looks, but because he was found near a river in Harbin, China, whose Chinese name translates to the Black Dragon River. He lived about 146,000 years ago, And it's thought that he may be representative of a population that was closely related to the Denisovans, but this is still a matter of debate.
A portrait depicts a man with wide nostrils, downturned thin lips, square jaw and deeply wrinkled brow with short brown hair in a ring around his tan face.
And then we have Homo naledi, and you may have heard about this population from about 10 years ago, when from Rising Star Cave in South Africa, there came the discovery of a remarkably large assemblage of fossils at the bottom of a long and very winding and twisting passage within the cave. The number of fossil specimens was over 1,500 at last count. And you can imagine the job that researchers had trying to figure out how many people were actually represented by these hundreds and hundreds of fossils. So far, there clearly were at least a dozen individuals at the bottom of Rising Star Cave. These people lived between 235,000 and 335,000 years ago. And they are thought to have had a combination of ancient and more modern features. Okay, so I hope I've shown you enough to convince you that whatever the course of human evolution was, it was not the straightforward line of ascent that we sometimes like to think of, from some monkey-like creature to somebody resembling a Greek god. It was definitely more complicated than that. And researchers have different ideas about how the various early human populations were related, or how they overlapped or interacted or did not interact. The visualization of how these early human populations were all related is thought by some researchers to look like a many branching tree, as we can see in a many branching tree. And other researchers picture the course of evolution as more like a sort of a bar chart, with the bars representing the different lifetimes of these various populations overlapping in time. And some researchers have come up with yet a different sort of bar chart, showing the various relations among early humans. And none of these is definitively accepted as the way human evolution proceeded. But as you can see, they're all quite complex, and they're all subject to revision as more fossils are found and more information is extracted from everything that is found. But what we do know is that however human evolution proceeded, we're all now here as one species, Homo sapiens, and however different we may look, and whatever different parts of the world we may come from, we are all just the one species now. And one thing I like about this illustration is it shows Homo sapiens doing one of the things we do best, which is talking and exchanging information. And I'd like to conclude with a slide that underlines the importance of exchanging information among humans, and in this case, early humans.
In a comic, one Neanderthal uses his empty speech bubble to hammer rocks. Another uses his speech bubble to say, no. Use it for talking, like this.
This is great, Sandra. If you have some more you want to share with us, please go ahead.
Okay, well, I do have a few more that are, I would say, more fun than scientifically, strictly scientifically based. So one of them shows how the idea of Neanderthals has been around in the popular imagination for a long time. And this is just one of the very many examples of artistic license that was taken with the idea of Neanderthals. Here they represent some kind of nemesis.
In a colored image, Batman punches a Neanderthal. Text: Neanderthal nemesis. No one had believed Robin when he had seen the fierce-looking caveman prowling near the camp. Now Batman knew it was true. But could he act in time to save the boy wonder?
We don't exactly know the motive underlying this dreadful attack, but apparently Neanderthals, as envisioned by this artist, were up to no good. Here's a very different rendering of early human populations. This is a reconstruction titled Denisovans and Neanderthals at Brunch. And we can't prove that something like this did happen, but we can't prove that it didn't happen either. And even here, you can see that, yes, they're eating brunch, but they're really mainly they're talking. And then we come to one that is one of my very favorites. And this is a drawing titled Peckham Rock. This is done by the graffiti artist Banksy on a piece of concrete, actually. And Banksy drew this and, in fact, smuggled this broken off piece of concrete with this drawing on it. He smuggled it into the Natural History Museum in London and put it on the wall in 2005. And there it stayed for 3 days, unremarked, until a museum staff member happened to notice a post on Banksy's own website that challenged viewers to find the hoax.
The image depicts a fake cave drawing on concrete of an outlined human figure pushing a shopping cart while pointing a sharp instrument at a distant bull impaled with arrows.
When this was brought to the attention of the staff, they said, well, the information label was just like the ones we use at the museum. And Banksy has now lent this work, Peckham Rock, back to the Natural History Museum for a permanent exhibition. And that's what I have.
Oh, thank you, Sandra. That was really fun. And I'm going to go ahead and jump right into some Q&A. And we'll actually, I want to start with one of our behind the scenes questions, which I think is a good one, given your profession. So with so much constantly happening in the field of human evolution, with science in general, what are some strategies that you use to keep up with new research or publications? Like, how can the average person stay up to date without feeling like we're always falling behind?
Well, I almost want to say that falling behind or feeling like you're falling behind is just part of the deal.
Mm-hmm.
But what I do is subscribe to everything I can get my hands on. There are a couple
Mm-hmm.
of major scientific journals. In the United States, it's Science, and in the UK, it's Nature.
Mm-hmm.
Kind of expensive to subscribe to, but they're usually available in public libraries because they are such major journals.
Mm-hmm.
And finds are very often announced in one or both of these journals. Um, there are a lot of good science writers out there, such as Carl Zimmer of the New York Times, our Ed Young of The Atlantic, who are really good at keeping up with the latest developments in human evolution and in a lot of other fields too, and also of putting new finds in context with what was already known.
Mhm.
And most researchers, in my experience, are actually quite happy to send you a copy of a new paper if you write to them and say, this was so interesting, I'd really like to read the paper itself. And what I do as a science writer is read the professional publication, the professional papers several times over, and then come up with questions that I can interview the researchers about.
No, that's a great answer. And you named two of my favorite science writers in that.
Yes. Yes.
Um, I will also say that as a researcher, I am always flattered when somebody emails me to ask for a copy of my original publication if it's not an open access paper. So I would fully support that for folks who are, enthusiasts of the field. Researchers really enjoy knowing that somebody's out there interested in the research. So,
Yeah. Yes. So there you go.
um, yeah. Let me ask another behind the scenes question. And we have a couple that I think will be fun. So, over your time in writing about human evolution, is there what's the one advancement or discovery or change in perspective that most surprised you or that you found most interesting? And maybe those are two different things.
Ah, yes. Well, a lot of it has been surprising. And in fact,
Mm-hmm.
not long ago, I gave a different talk titled The Ever Surprising Science of Human Evolution. I mean, it almost consists of surprises. Uh, but I remember that the identification of Denisovans was a big shock. Um,
Mm,
and the fact that that identification was based at first on such a tiny fossil and mostly on ancient DNA
mm-hmm.
left some people a little bit skeptical for a while. But since more fossils have been found, it's become pretty much a matter of course that there were Neanderthals over in Europe and Western Eurasia, and there were Denisovans in Asia.
Mm-hmm.
Um, Another big surprise for me was the definitive finding that these different populations of early humans did interbreed. We don't know how often this happened. We don't know how often they encountered one another, for that matter. Um, but they were able to have offspring who in turn had offspring of their own. So the way we had been thinking about these different populations as different species of humans doesn't really hold up. If you're going to hold to the classic definition of a species as a population that cannot produce fertile offspring with a different species.
Mm-hmm.
And it really has blurred the categories tremendously. And I've tried to pin down researchers sometimes about their use of the word species, and it's just it's just in flux right now. And so many researchers prefer to talk in terms of human populations or forms of early human. And I think this is something that won't be settled for a long time.
I agree with you. And I think, we see my understanding from researchers that work in the modern world is that we see species interbreeding in the modern world a lot. And so, these boundaries themselves are fuzzy and kind of change over time. So it gets really tricky to even think about in the fossil record, where, like you said, we don't have all of the pieces. And actually, this leads well into a question that we have from the audience from Tad, who asked, I'd like to ask what we know and don't know about species interbreeding that you discussed, Sandra. Do we know whether it was mostly Homo sapiens men, Neanderthal women, or vice versa? Do we know who raised the children? Um, or anything like that? Like, how do we know? Do you know if we know anything about that? How might we know about that? I think tough questions, but if you have any thoughts on that.
Um, well, I think first of all, there are very few fossil examples of individuals who have a parent of one human population and a parent of a different human population. This doesn't mean that it was extremely rare, but it just, in the context of how rare fossils are anyway, it just makes it hard to quantify. And I don't know that we'll ever be able to come up with a estimate of how common this was. But the fact that any fossils at all have been found that definitively show mixtures of two early human populations indicates that it must have been somewhat common.
Mhm.
I'm 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 trying to be as vague as possible.
That's
Um,
fair. Yeah.
but we also know, and I think this is pretty widely known now, that Homo sapiens and Neanderthals did a fair amount of mixing and interbreeding. And we know this because many humans today have 2 or 3 or maybe even 4% of Neanderthal ancestry way back in their genetic heritage. And
Mhm.
we know too that some populations that live in the South Pacific and also some people that live in Tibet show Denisovan ancestry. So these are modern day Homo sapiens who who are walking evidence, living, breathing evidence that this interbreeding went on, and it must have gone on more than once, and we just don't know how widespread it was. It was widespread
Mhm.
enough that there's still people around today carrying that evidence.
Exactly. And I think a fair proportion of people. So, yeah.
Yes.
Here's a really interesting question from Marcia, who asks, over the years, our understanding of human evolution seems to involve some projection by male experts and now perhaps women. How do we account for our own assumptions and subjectivity?
Well, that's a really good question. And
Hmm.
in my experience, the only way to account for it is to be aware of it. The
Hmm.
more of our assumptions we can explicitly recognize as our assumptions, the better able we are to work around them. And I think this is sort of the point I was getting at in talking about the terms that we use, um, and the place names even that we use. And the whole idea of out of Africa, which is a very important concept, but which at the same time was totally meaningless to the people who actually accomplished this. And in
Hmm.
fact, there was not just out of Africa. We know now that there was back into Africa. There
Hmm.
was wandering around between Africa and Arabia and Eurasia. And in fact, I have one quote from researcher Benjamin Verneau. I don't know if
Hmm.
you know his name, who years ago said on Twitter, after publishing a paper that very carefully examined all this, said, we might as well just put a disclaimer at the end of every paper that says everybody was wandering around and sleeping with one another. And really, the more evidence that turns up, the more it begins to seem like this may not be an exaggeration.
I really like that. I think that's probably very realistic.
Yes,
So, and that's what makes some of these things so difficult to reconstruct, I think. It
exactly.
wasn't just like single migrations in one direction, that kind of thing.
Right.
So here's a question that I think is a great question thinking about terminology from Malcolm, who says, there's not a strict definition of human in quotes, right? Much disagreement about which species qualify. And I guess I would tag on to that for you as a science writer. How do you use the word human, I guess, when you're writing about human evolution?
This has been a huge question for me. And in fact, it has been the impetus for this book project that I'm working on now. And as you can tell from the working title of the project, what makes us human?
Mhm.
Other titles I considered were How Do We Know We're Human? Or Who Says We're Human? Um, it's a term that has really blurred around the edges a lot. And I try to follow the lead of the researchers in the field to the extent that there's any kind of general agreement. And I've seen in the years that I've been writing about human evolution that there seems to be, and correct me if I'm wrong, Briana, about this, but there seems to be a tendency to extend the use of the term human further and further back into the genus Homo, so that even Homo erectus of 2 million years ago, which was really quite a different creature from us, um, was in some ways, is now considered in some ways an early human. But
Mhm.
I think there is a pretty clear-cut border with the genus Homo, and that still leaves plenty of room for very blurry categories within that.
Yeah, definitely. And I think I have also seen that trend where I think more often, at least in the past, the term human I had seen mostly used for our species, for Homo sapiens, but I have seen it being used, like you said, for potentially any member of the genus Homo. And I think there's not consistency among researchers, but definitely I have seen a little bit of a trend towards being more expansive about what the term human is
Yeah, I
or
would love to
refers
see
to.
it. Sorry, I would love to see a whole scientific meeting convened about the question of how are we going to use the term human? And it would be a very lively discussion, probably not resulting in any consensus, but it would be great to
It
have.
would be really interesting, actually. That would be cool. I want to ask, let me see. There's two questions in the Q&A that are kind of similar, so I'll bundle them and recognizing that like these also may be like they're speculative questions, but any thoughts about them? So one question is from Terry, do you think a new species might evolve at some point, or are we done? And then Ben asks, evolution happens so slowly we can't see changes within generations. My imagination likes to think about how we're evolving now. Any projections on our characteristics in several thousand years, given that our environments remain?
Wow.
Those are
Okay.
those are questions that often when I get, I'm like, but yeah, I'd love to know from your perspective or from like the scientists that you've talked to. Have people speculated about this kind of thing?
Well, most of the scientists I've talked to have shied away from projecting anything that they found
Yeah,
into the future
yeah.
because um, they have their hands full with what they are already working on. And
Hmm.
I also would say that it's now very clear that the environment isn't unchanged, and that's going to keep changing. Um, uh, but to the extent that all of us members of Homo sapiens travel around a lot more than we used to,
Mm-hmm.
and populations from different parts of the world mix freely, I'm inclined to think that there won't be a huge amount of further human evolution. Um, but I'm also, I feel compelled to add that depending on how we take care of our environment, um, there may not be an indefinite amount of time in which
Mm-hmm.
humans may be able to evolve. So it's in our hands now, and I think that's a good reason to remember that everybody is in this one species and we're all in this boat together.
I think that's a great answer to that question. And I agree. As you know, I have been asked to speculate about the future of human evolution, and it makes me feel a little squirrely, very squirrely. Um, and I think thinking about the sort of will will there be speciation is like a different question than are sort of humans evolving today, when we certainly know that in the realm of diet, health, our immune systems and things like that, we see lots of, what is sometimes termed microevolution happening with diseases particularly. And evolution, as when some of our other hot topics have talked about evolution in extreme environments and those sorts of adaptations. So yeah. Let me see. I'm gonna go. Actually, here's a question from Anne. It's also another sort of content question. But do we know yet from which species Homo sapiens came from? And I guess, is that something you're thinking about as you're thinking about your book?
I love that question because the point that I hope to make in the book is that we didn't come from any one particular location or any one particular early human population. We really are kind of a mutt species. And I think that's a wonderful thing because what gets preserved in generation after generation is, for the most part, the adaptations that work and the genetic changes that function well. And this was the point of that drawing that I scribbled a red line over. It's just not really possible anymore, given what has been found, to point to the origin of Homo sapiens. There clearly were multiple origins mixing in together.
Yeah. Yep. We have a couple of more behind the scenes questions that I'd like to ask before we wrap up. And one of them is, if you have one, what is your favorite hominin fossil or species or site, and why?
Oh. My favorite, I don't have a favorite fossil, but my favorite site varies with what has just been found. There's one site in France that particularly fascinates me. It's a cave called Bruniquel, and it's a very odd place where there are dozens, maybe scores of, let me see if I remember, is it stalagmites?
Or
Rise,
stalactites. I can't
yes.
remember which one. Yeah.
Okay, thank you. Rising up from the ground of this, inside this cave, arranged in a circle, a kind of a rough circle, but the site has been dated to, I think, 170,000 years ago, and it's just mystifying what was going on in the minds of those people. You have to call them people who did this. I mean, imagine how long it even took. Some of these structures were broken off at a particular height to make them the same height as the ones next to them. Some of them are propped up carefully against other ones. And I don't know how it will be even possible to find out what the heck was going on in there, but I hope somebody will take it up. And to me, that also indicates clearly that speech of some kind goes back very far in human evolution, a couple of 100,000 years at the very least, because there's no way you could carry out an art installation like that without being able to talk to the other people. And even cave paintings, some of which are very old, show clearly, I think, that there must have been speech, because inside those caves there had to have been one person holding a source of light, and at least one other person mixing up the pigments and applying them to the wall, and who knows how many other people, standing back and commenting, perhaps. Who
Group art.
Yes, early human art critics, who knows? But anyway, it's impossible to think of arranging things like this without speech. And although speech is not preserved in the fossil record, we have really, I think, strong indications of it going way back.
Oh, that's a very cool answer. And actually, we got some great comments from. So Laura says, from the ground stalagmites. I will remember that.
Thank you.
And Tina says, stalactites stick tight to the ceiling, and
Ah,
stalagmites might if they could. This is great. I'm learning a lot.
yes,
So I
great.
will remember that now. So here's a good way, maybe our second to last question. What would you say is the biggest misconception among the general public about human evolution, and what strategies do you have or use to try to rectify that?
Uh, well, I think we all, at least in the United States, have images of the Flintstones in our minds, and we we just really, for whatever reason, we're just very fond of the idea of these cavemen, and of course they were just men at the time.
Right,
Um,
sure.
that it satisfies some need we have of people who came before us being somehow not quite up to our standards.
Hmm.
But the strategy I hope to be able to use to counter this is to describe as many examples as I can of human-like behavior. And I think in showing you that father carrying the child on his shoulders, uh, who knows how many hundreds of thousands of years ago that was, and a lot of other examples like that, I think it will, I hope it will chip away at the idea that early humans were simpler than us in some way, or more primitive, or just not quite as well developed
Hmm.
as we think of ourselves today.
That's really helpful. And thinking about your science writing to help with like strategies to show all of the ways in which these different, early human species or populations had the same sorts of abilities or things like that our species does. That's pretty cool. Um, so the last question, and thank you, Carolyn, for also giving us another way to remember stalactites hang tight. I like that. So the last question that I want to ask is also a behind the scenes question that I've actually been wondering also, what got you into science writing and what drew you to human evolution, including, of all the other science topics that you could write about?
Um, well, I knew I wanted to be a writer, and I always knew this. And I decided sometime in college that I would go into science writing, science publishing, because I figured, I thought it was a cold-blooded decision, that there would always be plenty of it. There would always be a need for this.
Mhm.
Um, and my first job was at American Scientist magazine when it was based in New Haven, Connecticut. And I started as an editorial assistant, the bottom rung of the ladder. But I was there long enough that through turnover, I got to do a lot of different jobs there. And it slowly dawned on me that among the entire spectrum of scientific fields, there were some I just really cared more about than the others. And the others, astrophysics, ah, no. Um, Geology, okay, maybe. Human evolution, I just found myself drawn to this. And what I like about the study of human evolution is that it brings so many other scientific fields in. And I think I like the multiplicity of that, just as I'm really pleased to think of the kind of multiple origins of humans. What was the other part of this question? I don't remember.
It was, yeah, what got you into it and what drew you to human evolution? So I think, yeah.
Yes, I've
Hmm.
covered. Yeah.
Yeah. No, thank you. That I also really like the interdisciplinary nature of human evolution, I think inherently as a science. So
Yes.
um Excellent. Well, thank you. So I'm going to conclude today's virtual program. So please join me in thanking Sandra for sharing her work with us. That was a really fun presentation and conversation. I'd also like to give special thanks to those who made this program possible, to our behind the scenes team who helped sort through your questions and write answers to your questions, including Dr. Ryan McRae, who works with us at the Human Origins Program, including our donors, volunteers, and viewers like you. And finally, to all our partners who help us reach, educate, and empower millions of people around the world today and every day. We thank you. So we are done with our hot topic programs for the spring. We'll be starting up again in the fall on September 18th with Dr. Bruce Hardy from Kenyon College. We've put a link in the Q&A to where you can find information about our upcoming programs and how to sign up for the museum's weekly e-newsletter. That's the best way to stay informed about our upcoming programs, Hot Topic and others, and to learn more about the museum's research and exhibitions. After this webinar ends, you'll see a survey pop up asking for some feedback about the program. Please take a moment to respond. We're very curious to know what topics you might be interested in seeing in future programs, and we appreciate your input. So again, thank you to Sandra, thank you to the audience, and we'll see you in the fall.
Text. National Museum of Natural History. Smithsonian.